What if an AI model could rewrite its own rulebook? Not just follow instructions, but redesign the entire system that governs how it thinks, works, and improves. That's exactly what MiniMax M2.7 just demonstrated. And it's not the only one. 5 independent teams, 6 weeks, one unmistakable pattern. AI agents are learning to evolve themselves. This changes everything about how we build with AI. I'm May, let's break it down. On March 19th, MiniMax released M2.7, a model they describe as their first to deeply participate in its own evolution. That sounds like marketing. It isn't. M2.7 ran over 100 autonomous optimization rounds on its own agent harness, discovering improvements no human engineer programmed, and achieved a 30% performance boost on internal benchmarks. The model didn't just execute within its scaffolding, it rewrote its scaffolding. And that distinction is what makes this a genuine phase transition.
AI learning from the data we give it, we're talking about one that can recursively improve its own core abilities. Can a machine really become its own teacher, its own engineer, and design its own upgrade? It's a huge question. So before we even get into the how, just look at this. On a really important benchmark for machine learning engineers, a brand new model called M2.7 just tied with Google's latest Gemini, and it's right on the heels of OpenAI's best model. This result, from a company that's pretty new on the scene, creates this central mystery. How on earth did they do that?
Okay, so to get how they pull that off, you gotta meet the company that just basically put the whole industry on notice.
So this is MiniMax. They were only founded.
Here's what M2.7 actually did, technically, not marketingly. MiniMax tasked an internal version of the model with a meta challenge: build a research agent harness, use it to run reinforcement learning experiments, and then improve the harness based on the results. The model's weights don't change, the training data doesn't change. What changes is everything in the harness layer, the skills, the memory, the orchestration code, the prompt templates, and the workflow guidelines. This is fundamentally what a human harness engineer does, except M2.7 ran 100 iterations, where a human manages maybe 5 to 10 per week. The acceleration is 10 to 20x in iteration speed, not in cognitive capability. Now the benchmarks tell a story most people aren't ready for. M2.7 scores 56% on SWE Pro, matching GPT 5.3 codex. On MLE Bench, it achieved a 66.6% medal rate across 22 machine learning competitions, tying Gemini 3.1 just behind Opus 4.6 and GPT 5.4. Skill adherence, 97% across 40 complex skills, each over 2,000 tokens. But here's the kicker. Karpathy's auto research was the proof of concept that made this possible. His 630 lines of code showed that bounded autonomous optimization works. M2.7 took that concept and turned it inward on its own harness. And MiniMax offers all of this at roughly $10 per month. When a $10 model matches GPT 5.3 on coding benchmarks, the premium model moat starts leaking. Let me give you the contrarian take. And I think it's the right one. Self-evolving agents are not a path to AGI. They're a path to better DevOps. M2.7's self-improvement loop is functionally identical to what a senior engineer does when they refine their team's CI/CD pipeline, update coding standards, and tune monitoring based on last sprint's incidents. The difference is speed and scale, not kind. That 30% improvement from 100 autonomous rounds? A good engineering team achieves similar gains over a quarter of focused process optimization. M2.7 just does it faster. And here's the strategic play nobody's discussing. MiniMax is a Chinese lab releasing a self-evolving model at $10 per month. They're not competing on model quality, right? They're competing on total cost of harness engineering. Or if your model improves its own harness, you need fewer human harness engineers. That reduces the talent bottleneck. And the talent bottleneck is exactly where Western labs have their biggest advantage. Self-evolving models are a talent arbitrage strategy.
Zero humans. The model analyzed its own failures, planned changes, modified its own code, ran evaluations, compared results, kept what worked, reverted what didn't, over and over 100 times. Performance improved 30%. Then they let it compete in 22 machine learning competitions autonomously on a single $4,000 GPU. 9 gold medals, ranked third in the world behind only Claude and GPT's best models. And if that company sounds familiar, MiniMax, some of you may use their software for image or video.
But before we celebrate, the blog raises risks that deserve serious attention. Goodhart's law applies with extra force here. If the model improves its own harness using metrics you defined, it will optimize for the metric, not for what you actually want. MiniMax's 30% improvement on internal evaluation sets sounds great, but who defined those sets? MiniMax. That's a claim, not evidence. And the competitive pressure is destabilizing. If self-improvement loops produce compounding advantages, labs with the fastest loops win everything, which creates intense pressure to reduce human oversight because humans are the bottleneck. The incentive structure pushes toward less safety, not more. Here's what makes this moment truly significant. M2.7 didn't emerge in isolation. In just 6 weeks, 5 independent teams converged on self-improvement from completely different angles. Karpathy open-sourced auto research, 630 lines of code, single GPU, 100 experiments overnight. He proved that bounded autonomous optimization works, and within days, the pattern crossed from ML research to finance. Someone adapted auto research into a live poly-market trading bot that autonomously experiments with arbitrage strategies. A paradigm diffusing in under a week.
It is you wake up, you grab the best version, and then hopefully you turn it into something you charge for, or you give it away. I saw this tweet by Toby, who's the CEO and co-founder of Shopify. Auto research works even better for optimizing any piece of software. Make an auto folder, add a program MD. That's just a markdown file, which is really the foundation of how you're going to be using auto research. And a bench script, make a branch and let it rip. So that's why I started paying attention to auto research, right? When Andre Karpathy, legend, and Toby and more people, started playing with it, I'm like, okay, I got to pay attention. So I created this little visual for how to think about what auto
OpenAI Symphony managed 1 million lines of production code, 100% agent written, with episodic memory that compounds over time. Agents get better at familiar task types by referencing their own successful history. Google DeepMind's AlphaEvolve went even further. It evolved the algorithms that search for solutions, breaking 5 Ramsey theory lower bounds simultaneously, one that had stood for 20 years. Anthropic's Skills 2.0 introduced evals and A/B benchmarks, the infrastructure for agents to iteratively improve their own capabilities. And Poetic, a 7-person startup, beat Claude Opus 4.6 on humanity's last exam by recursively self-improving their reasoning harness. The pattern across all 5 is identical. Nobody is modifying model weights. Everyone is modifying the scaffolding. So what does this mean for your career? The skill tree just forked again. Before harness engineering, your value was in writing code. After harness engineering, your value shifted to writing constraints that govern agent code. After self-evolving agents, your value is now in writing meta constraints, the evaluation criteria, safety boundaries, and objective functions that govern how agents improve their own constraints. You're no longer asking what should the Claude MD say. You're asking what should the system that writes and evaluates Claude MD files optimize for. And here's the uncomfortable career question. The "don't worry, you'll just manage agents" narrative has a shelf life. If the harness itself is just text, and it is Claude or MD as a markdown file, then the management layer isn't immune from automation either. But here's the thing. That endgame is still measured in years, not months. And right now, engineers who understand evaluation criteria and safety boundaries are extremely rare and extremely valuable.
Nice. And it looks like, yeah, this is reflective of the fact that you have put a lot of thought into those design patterns. Our app here gave you a B grade on your agentic legibility.
Nailed it.
There's a few things. So let's take a look at what it scored and its recommendations, right? So bootstrap self-sufficiency, basically, can the repo just get set up from scratch, right? Do you need to know, is there external knowledge that you might need to know, or commands that you might need to run to make this work, right? Task entry points. So is it easy for the agent to just run, make or build or lint or that sort of thing, right? validation harness. So how
Here are
easy?
the predictions I'm watching. Within 6 months, every major agent platform will ship native self-improvement mode. Too obvious and too easy not to happen. Within 12 months, self-improving harnesses become a product category. And the safety line is at step 3. Harness self-modification is bounded. When systems start modifying their own evaluation criteria, deciding for themselves what good means, that's when the debates become urgent. We're not there yet, but the path from step 2 to step 3 is shorter than people think. 3 weeks ago, the harness mattered more than the model. Today, the models are learning to build their own harnesses. Read the full analysis on computeleap.com. Link in the description. That's the deep dive for today. If this changed how you think about AI, hit subscribe. We go deep every week, not just headlines. Full article with all the sources is on computeleap.com. See